For over 60 years, astronomers thought they had this one star cluster in Sagittarius completely figured out. They thought they knew its story inside and out. But it turns out it was hiding a colossal secret, and it was part of something so much bigger than anyone ever imagined.
So, what if everything we thought we knew was just incomplete? What if we were only seeing one small piece of a much grander and way rarer cosmic structure? Well, let's dive in and find out. Now, to get to the bottom of this cosmic mystery, we're not going to start with the big picture. Nope. Instead, we're going to zoom way, way in and focus on one single remarkable star that turns out to be the key to this whole thing. Her name is U Sagittarii. Now, U Sagittarii isn't your average star. It's a Cepheid variable, and these things are amazing. The best way to think of them is like cosmic lighthouses. They pulse, getting brighter then dimmer. And the rhythm of that pulse is directly tied to their actual brightness. So we can compare how bright they really are to how bright they look from Earth, and boom, we can measure huge cosmic distances with incredible precision. They are absolutely essential for mapping the universe. So our star, U Sagittarii, or USJR for short, has this perfect, steady rhythm. It brightens and dims every 6.75 days, just like clockwork. And for the longest time, it was considered the main event, the most important member of its home star cluster, a place called M25. This star was literally the anchor of the whole story. Okay, so we've met the star. Now let's zoom out just a little bit. Usagar isn't a loner. It lives in a bustling stellar city, an open star cluster known as M25, which, again, astronomers have been studying for decades.
And you can immediately see the challenge astronomers have been up against. M25 is located in this incredibly crowded part of the sky, right in the direction of the center of our Milky Way galaxy. It's like trying to pick out your friend in the middle of a packed stadium. Trying to figure out which stars actually belong to the cluster and which are just photobombing from the background or foreground, well, it's a huge challenge.
So what did we think we knew about this cluster? Well, based on lots of studies, we had it pegged at about 600 parsecs away. A parsec is just a big unit of distance astronomers use. To put that in perspective for you, 600 parsecs is almost 2,000 light years. We're talking seriously, seriously far away. We also had a pretty good handle on its age. At around 94.5 million years old, it's basically a cosmic teenager. It's really young for a star cluster. And we knew it was a pretty popular place, with over 220 confirmed stars calling it home, including our famous Cepheid, U Scrar. So it seemed like a nice, well-defined family, or so we thought. But looking at M25 has never been easy. On top of all the stellar crowding, it's also hiding behind these veils of interstellar dust that block and scatter its light. And to top it off, its position in the southern sky makes it tough for many of the world's biggest observatories to get a clear view. And trust me, these challenges are a huge part of this story. And that was pretty much where things stood, a well-known, if tricky, star cluster with its famous pulsating star. For more than half a century, that was the complete picture. And then everything changed. This new research came out just this year, and it reached a conclusion that was both incredibly simple and absolutely stunning. M25 is not alone. Not by a long shot. Okay, here's the big reveal. Using some ridiculously precise data from the Gaia satellite, astronomers discovered that M25 is actually one of 3 star clusters, all moving together through space as a single group. This newfound cosmic family is now called the Sagittarius Triad, and it's made up of M25, NGC 6716, and Colander 394. This is a perfect way to picture it. For decades, everyone was focused on this one single tree, M25. Nobody realized it was actually part of a rare ancient grove of 3, all connected by their roots, hiding in plain sight the entire time. So the big question is, how did they pull this off? How do you even begin to find a hidden family connection between billions of stars separated by these vast distances? Well, the key is a science called astrometry, and the absolute game-changing tool for it is the European Space Agency's Gaia satellite. Gaia is essentially building the most precise 3D map of our galaxy ever attempted, tracking the positions, distances, and movements of over 1 billion stars. It's basically a cosmic detective with an eagle eye. So here's how the discovery went down. First, researchers dove into Gaia's massive database. They found that these 3 specific clusters were all moving through space together, kind of like a flock of birds in formation. Then, they confirmed they all had a similar age, about 80 million years. But the final, critical piece of the puzzle was correcting for all that interstellar dust we were talking about.
And this was the big aha moment. Once they mathematically wiped away the effects of that obscuring dust, the true nature of the stars in all three clusters just snapped into focus. It was like cleaning a really dirty window and suddenly seeing a perfectly matching set of furniture inside. They had a shared family signature. And the evidence is right here in the data. Just look at this table. The ages are nearly identical. The Gaia parallax, which is that super precise measurement of their distance, is incredibly close for all three. And get this, the two biggest clusters each have their own special star. The data is just undeniable. These three clusters were born together, and they've been traveling together ever since. Okay, so we found a celestial family. It's a fantastic discovery for sure, but you might be asking yourself, all right, why is this so important for astronomy? Why is a cluster triad such a big deal? Let me put this in perspective for you. Most open clusters are pretty fragile. The gravitational pull of the galaxy usually rips them apart in about 10 million years. This family has survived and stayed together for roughly 80 million years. It's a cosmic survivor beating the odds by a factor of 8. That's incredible. This makes the Sagittarius triad a truly rare specimen. Its survival gives us a unique natural laboratory to test our theories about how star clusters form and evolve. And because it hosts our Cepheid friend U-Squar, it's a vital anchor point for calibrating those cosmic distances I mentioned. And as a final little twist, another Cepheid nearby, BB-Squar, might actually be an escaped family member, which just adds a whole new layer to the mystery. And all of this leaves us with one final, tantalizing thought. The Sagittarius triad was right there, being studied for decades, but it was never truly seen for what it was. It just makes you wonder, with powerful new tools like Gaia constantly mapping our galaxy, what other cosmic families are out there, hiding in plain sight, just waiting for us to connect the dots?